All right, so we're continuing with 3, 4, which was completing the square and then finding whatever you need to find from the conic. So number 5 looks like this. The first thing you want to train yourself to look for in these is the squared terms, right? So how many squared terms are here? 1, which means this is going to be what when we go to graph it? A parabola. And that's important for 2 reasons. 1, what to do with it once you get it to that point. 2, standard form looks different depending on if it's a parabola or an ellipse or a hyperbola. So it's important to know what the goal is at the end. Yeah.
What did she say
There's only 1 squared term. Yep. So because that squared term has a y on it, I'm going to group together the y's and I'm going to bump everything to the other side. So I'm going to take the negative 2y squared and the minus 20y, leave it on one side, and then push everything to the other side. So subtract the x and add the 49. Now I could have reversed this. I could have put the y squared on the other side, making it positive, but then it doesn't match what we've been practicing as our standard form. And if you're a really visual, God bless you, if you're a really visual person, then it's important to kind of match our formulas. And the formula with the squared was y minus k squared equals 4px minus h. So when it's a y squared, that's the standard form, a y squared with a vertex not at 0, 0. And so it's important that we keep the squared on the left side. If you can switch that in your mind and you can switch that visually, then it's totally fine. You could have switched these sides. So now I got to work with the squared terms. I would want to complete this square, but before I do that, I have to take out the negative 2. So the negative 2 goes on the front of the parentheses. When you take that negative 2 out, it becomes y squared plus 10y. Be careful and make sure you divide that second term by the negative 2. And now we want to complete that square. So I'm going to take the 10, divide it by 2, that's 5, square it, it's 25. And that's what we're going to add to inside the parentheses. And we would normally add it to the other side to balance out that equation. But because we took something out of this parentheses, I need to multiply it by it first. Which means I'm now subtracting 50. So the negative 2 stays on the front. I factor what's inside the parentheses, square root the y, squared it's y. Square root the 25, it's 5. Take the sign from the middle, it's plus. Put it in parentheses and square it. And set it equal to negative x minus 1. Now there can be nothing on the front of our y squared term, which means I have to get rid of the negative 2. I'm going to divide both sides by negative 2. Which on the left side, it will cancel out and I get y plus 5 squared. On the right side, I can't have anything attached to the x. So you have 2 choices here. One is multiply the whole thing by a negative 1/2, because that would be the same thing as dividing by 2. Or change it so that it's 1 over 2x plus 1 over 2, because that's what would happen if I divided this and this by it. And then take out the 1/2, because there can be nothing attached to the x either. So 1/2 on the front makes this x plus 1. So you can't have a number or even a negative sign attached to either of those variables. There can be nothing in the front of the squared term. And then on the x to the first, you got to make sure it's separated out by that parentheses. So we could have also just done negative 1/2 here times negative x minus 1 and then change the signs to make it a positive x inside. And it would have been the same, whichever one makes the most sense to you. So here's my parabola in standard form. What do we know about this parabola? Which direction does it face? To the right, because it's a y squared and it's a positive 4p. What's the vertex? Negative 1, negative 5. So I go negative 1, negative 5. Plot my vertex, point it towards the right. 4p equals what? What's on the front of the parentheses? 1/2. So I divide by 4 or multiply by a 4th, and p is 1/8.
What is
The distance from the vertex to the focus and the vertex to the directrix. Yep.
do you know what's called right?
It's a y squared and a positive 4p. So y squared is right and left. If it's positive, it points to the right. If it's negative, it points to the left. X squared, up, down. Positive up, negative down. You're welcome. Okay, so 1/8 is to the right, 1/8 is my focus. So I would take the x coordinate of my vertex, which was -1, and add 1/8 to it. And that's -7/8 and -5. And then I move 1/8 to the left, and that's my directrix. Directrix is a line, so it has to have an x equals or a y equals. This would be an x equals because it's a vertical line. And I take my x coordinate and I subtract the 1/8 because I'm moving to the left. So it'd be -1 and 1/8, or -9/8 if you want to leave it improper. It has to have the x equals, or you lose those points for the directrix. Directrix has to be a line, so it's an x equals or a y equals. Questions on that one? Yep.
Is the test
No. All right. Go to the next one. How many variables we got squared? 2. Are their signs the same or different? Different. What does that tell you? Hyperbola. Good. So I'm going to group together the x squared and the -2x. I'm going to leave this space so we can complete that square. The y squared does not have a y, so I don't have to complete the square for the y, but I do need to keep it on the left side. And then I need to move the 8 to the other side, so add the 8 to both sides. Yep.
How'd you know that it was, you said it was a
Hyperbola. If 2 are squared, like the x and the y, and they have the same sign, it's an ellipse, opposite signs, and it's a hyperbola.
Okay.
So if they're both positive or both negative, it's an ellipse. If they're both, which they'll end up being both positive. And then if the one's positive, one's negative, it's a hyperbola.
Thank you.
You're welcome. Yeah.
Why didn't you move the y over to the other side?
Because it's a hyperbola, we keep the x's. Anything that's squared, we keep on the same side. Hyperbola and ellipse, you would keep them both. All right, now I got to complete the square with that first one. So I take the 2, divide it by 2, it's 1, squared, it's 1. I add the 1 inside the parentheses, and I add it to the other side of the equal sign. And I factor the left side. Square root the x squared, square root the 1, take the sign from the middle, put it in parentheses, and square it. Minus y squared equals 9. Now, if it's a hyperbola, what do I have to do to get it into standard form? Good. Divide everything by 9. It's got to be equal to 1. So I get x minus 1 squared over 9 minus y squared over 9 equals 1. That's the standard form of my hyperbola. And for some questions, that might be all you have to take it to. But then there's going to be other times when it then says, okay, now find all the things about the hyperbola. So that's why we're going to just keep practicing in that way. So tell me what you know about this hyperbola. Center is 1, 0. Good. Opposite of x, opposite of y, of what follows x and what follows y. What else do we know? A squared would be 9, and they're both 9, right? So why is it 9? Or how do you identify a squared? First one. And a hyperbola is first one. So a is 3 and b squared is 9 and b is also 3. That can't happen in an ellipse. It actually makes it a circle. But in a hyperbola, they can totally both be the same thing. Yep.
So for hyperbola, it's whatever comes first instead?
Correct.
And for the ellipse, it's whatever's bigger?
Correct. You're welcome. And then because though x is first, what kind of hyperbola is this? Horizontal. We're going to practice our asymptotes. If it's horizontal, it's y equals k plus and minus b over a times x minus h. Horizontal is b over a, vertical is a over b. And we're going to practice the foci too. For that, we need c squared. And c squared equals a squared plus b squared with a hyperbola. C squared would equal 9 plus 9, which is 18. Square root of 18, which is 2 and 9, gets simplified to 3 root 2. And would be like a 4.2 if we approximated it because it's just a little bit bigger than the square root of 16. Yep.
How do you know which one is
The x squared comes first. All right, so I start at my center, which is 1, 0. I'm going to go up and down 3 and right and left 3. If it was horizontal, I would normally lead with the A, but again, they're both the same. So right to the 3, 1, 2, 3, left 1, 2, 3, and those are your vertices. Negative 2, 0, and 4, 0. It's what you would get by adding and subtracting 3 to the x. Then I would go up and down the B, which is also 3. And those are my co-vertices. 1, 3, and 1, negative 3. I would draw my box. Find the corners. And draw the asymptotes. Yep.
I'm sorry, how do you find the vertices and co-vertices?
You count right and left the A because it's horizontal. So vertices are A. Right and left because it's horizontal. Up and down the B. And then we draw our branches, and this is horizontal, so the branches go to the right and to the left. If I wanted to graph, or if I was asked to graph the foci, I'd be going right and left approximately 4.2 on my graph. So 1, 2, 3, 4.2, 1, 2, 3, 4.2 would be the foci. But then when I give those coordinates, they would have to be exact. So I'd take the x, which is 1, and I add and subtract the exact root, which is 3 root 2. And then I leave the y alone. And then the asymptotes, we plug our information into here. Y would equal the k is 0, plus and minus, b is 3, a is 3, x minus h would be x minus 1. And that would simplify to plus and minus x minus 1. Yep.
A would always be the bigger one.
For an ellipse, yes.
And for this one, it's always
First. Mm-hmm. All right, go to 7. So in looking at our variables, how many are squared? 2, same sign or opposite sign? Which means it's a hyperbola again. So I'm going to group the x squared and the x together. Negative 25x squared minus 100x gets grouped together. I'm going to complete that square. And again, the y squared doesn't have a y, which means I only have to complete the square once. I'm going to bump the 125 to the other side. If there was a y squared and a y, I would have to do it, complete the square twice. Now I take out the negative 25, and this becomes x squared plus 4x. I take the 4, divide it by 2, that's 2, square it, it's 4, so I add the 4 inside the parentheses. And I would normally add 4 to the 125, but I have to multiply by negative 25 first. Whatever I took out gets multiplied first, which changes this to subtract 100. So I get negative 25, square root the first term, that's x, square root the third term, that's 2. Take the sign from the middle, put it in parentheses and square it. Plus y squared equals 25. Then what? Divide everything by 25. Hyperbola and ellipse would have to be equal to 1. This becomes a negative x plus 2 squared plus y squared over 25 equals 1. And you can leave it over 1 to remind you that that value would be 1, so you don't think it's 0, but you don't need it. Yeah.
You're dividing it by the 25 that's like...
On the right. Yeah, the one that it equals. And then because it's a hyperbola, the first term, the leading term should be positive, so we want to switch these two. So it becomes y squared over 25 minus x plus 2 squared over 1. Again, you don't need the 1, but the 1 will remind you that that is still there. And that's your standard form. Yep.
Why would you switch it?
Because the leading one has to be positive. Okay, now tell me what we know about this hyperbola. It's vertical because the leading one is y. And vertical, my asymptote is y equals k plus and minus a over b, x minus h. Somebody else said something. Good. Center at negative 2, 0. What else? Good. A squared is 25, so A is 5. B squared is 1, so B is 1. And if I wanted to find C squared, it would be A squared plus B squared, which would be square root 26. And that just simplifies to 2 and 13, so it doesn't simplify. And we would approximate it to be just bigger than 5, like 5.1. Yep.
So hyperbola is two things squared with different signs, and an ellipse is two things squared with the same sign?
Correct. Yep.
And when it's horizontal, that equation is just 2 over a.
Correct.
Is there like a reason for that?
Yeah, your slope changes. So you'd go up the B and over the A if it's horizontal, and it reverses. You're figuring out your slope. You'd go up the A and over the B if it's vertical. So it's just determining your slope, which is how you make that box. That box is made by the slope.
So for this, you go up a and...
Right and left B. Yep. All right, so then my center is 2, 0, or negative 2, 0. It's vertical, so we go up and down the A. I'm going to go up to 5 and down to negative 5. Those would be my vertices. Negative 2, 5, negative 2, negative 5. I'm going to go right and left the B, which is 1. Those are my co-vertices. Negative 3, 0, negative 1, 0. I would draw the box. Find the corners. Draw your asymptotes. And then it's vertical, so this comes off the top and the bottom. And the foci up and down about 5.1. So just past the curve. And kept exact, we would add and subtract the C from the Y coordinate. So -2 plus and minus square root 26. And then the asymptote, Y equals K is 0, plus and minus, this time it's A over B, so 5 over 1, X minus H, and H is -2, so this becomes plus 2. And it's plus and minus 5, X plus 2. Yep.
How do you know which one is like which term or multiplication?
The A over the B and the B over A, you mean? What do you mean?
Like how do you know how to place each one of those numbers?
K is the Y coordinate of your vertex. A is your A, B is your B, and H is your X coordinate of your vertex.
Wait, A is, what did you say after A?
And H is the X coordinate of your vertex. You're welcome.
Will 3.4 be on the test?
No. Yep.
For the foci, how do you know if it's like inside or outside of the
It's
box?
always inside the scoop.
Okay.
So it'll always be outside the box.
Okay.
Yep. In an ellipse, it's inside the hyperbola, inside the ellipse. So C is going to be smaller than A, whereas here it's outside, so C is always bigger than A.
So for the hyperbola, it's on the outside of the
Correct. Because if you think about it, C squared is A squared plus B squared, so C has to be bigger than A in here. But on an ellipse, it's C squared equals A squared minus B squared, so C has to be smaller than A. Yeah. Questions? So I took this one out and then complete the square for the Y. Take the 4, divide it by 2 and square it. That's 4. Added it here. Before I add it here, I have to multiply by the 25 that's on the front, making it change to adding 100. And then I got this line. So negative 9x squared plus 25, parentheses, y minus 2 squared equals 225. Because it's a hyperbola and it would be the same for an ellipse, I need it equal to 1. So I divide everything by 225. And I get x squared over negative 25, or the negative out front, doesn't matter where that negative is, plus y minus 2 squared over 9 equals 1. And then we reverse it because it's the hyperbola. We want the positive 1 to come first. So now this is a y squared, or leading y squared, which means this is a vertical hyperbola. The center would be at 0, 2, opposite of what follows x, opposite of what follows y. The a squared is 9, making a 3. The b squared is 25, making b 5. Because it's vertical, my asymptotes are y equals plus and minus, or k, sorry, plus and minus a over b, x minus h. And c squared equals a squared plus b squared. C squared would be 34. C would equal the square root of 34. Breaks down to 2 and 17, which doesn't go anywhere. So I'm going to keep that exact for my actual foci. When I graph it, I would start at my center being 0, 2. I would go up and down A. So I'm going up 3 and down 3. That makes my vertices 0, 5, and 0, negative 1. I go right and left 5, which makes my co-vertices 5, 2, and negative 5, 2. I make the little box. I find the corners. I draw the asymptotes through those corners. And it's vertical, so my branches point up and down. The foci, square root 34 is going to be close to square root 36. So let's say that's like a 5.8. I would go up almost to 6 and down 1, 2, 3, 4, 5, 6. Oh, not almost to 6, sorry. From 2, I would go up 1, 2, 3, 4, 5, almost to 6 there. And then down 1, 2, 3, 4, 5, almost to 6 here. And I'm going to keep those points exact when I give it as the foci. So the x doesn't change. The y becomes plus and minus the square root of 34. Or 2 plus and minus the square root of 34. And then the ellipse y equals the k is 2 plus and minus a is 3, b is 5, x minus 0. And I would get 2 plus and minus 3/5 x. Questions on that one? Yeah.
Where'd you get the 2 for
The 2, so foci we're adding and subtracting to the y coordinate of your center. Since the y coordinate of my center was 2, I take the 34 and add it, or square root of 34, and add it and subtract it from there. All right, the next one only had one variable squared, so I know this is a parabola. I'm going to keep the y squared and the 10y on the left. I'm going to move the x and the 26 to the right, making them both negative. Complete the square for the 10. 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to the left and to the right. Factor the left side. I get y plus 5 squared equals negative x minus 1. There's nothing in front of the y squared, but I have to take this negative off the x. So I bring it to the outside of the parentheses, and it comes and changes the x and the 1. Yeah. So this is a parabola that faces to the left because it's a y squared with a negative 4p. My vertex is at negative 1, negative 5. My 4p is 1, so p is 1/4. Which means when I graph this, negative 1, 1, 2, 3, 4, 5, negative 5, and I point it to the left, I would go left 1/4 to get the 4p, which means from that x, I'm subtracting the 1/4, and my focus would be negative 1 and 1/4 and negative 5. And then my directrix is 1/4 to the right of my vertex. So I'm going to take that negative 1 and add 1/4 to the vertex, and I get my directrix. It's a vertical line. So it's an x equals, and negative 1 plus 1/4 would be negative 3/4. Yep. I took 10, divided by 2, and then squared it. So you complete the square for the y. All right, 10. Again, 2 variables squared. This time, weirdly, one's on the left, one's on the right. If I have 2 variables squared, what kind of ellipse am I looking, what kind of a conic am I looking for? It's going to be an ellipse or a hyperbola, right? In either of those cases, the squareds have to be on the same side. So I'm going to move the squareds, anything with a variable to the left, and I'm going to move anything that's a constant to the right. Before I figure out if this is an ellipse or a constant, an ellipse or a hyperbola, because the signs have to be on the same side to figure that out. So I'm going to add the 16y squared. I get negative x squared minus 32y plus 16y squared equals 125, or 128. Now I know there are 2 variables squared with different signs, so this is going to be a hyperbola again. I'm going to group together, and you can rearrange this any way you want. So if I already know that the x is negative, I could totally do 16y squared minus 32y first minus 9x squared equals 128. I have to complete the square for the y, so I take out the 16. Take the 2, divide it by 2, that's 1, square it, it's 1, so I add 1 here. And before I add it here, I have to multiply by 16. I get 16y minus 1 squared minus 9x squared equals 144. And divide everything by 144. Y minus 1 squared, this is 9. X squared, this is 16. So I know this is a hyperbola. I'm not going to go all the way through just because we've done it a bunch of times, but it's a hyperbola. The y squared is first, so it's vertical, which means my equation would be an a over b for the asymptotes. My center would be 0, 1. A squared is 9, so a is 3. B squared is 16, so b is 4. So again, I won't go all the way through, but from my center, I would go up and down 3. Those would be my vertices. I'd go right and left 4. Those would be my co-vertices. And then if I needed the asymptotes in the c squared, I would do the c squared equals a squared plus b squared because this is a hyperbola. Questions on that one? Okay, this is the PDF from the day before yesterday, so if you want to get that opened. The last question did have a typo because it made it impossible to do. As long as you even attempted it, I still give you the full credit for it. But I do want to go over like why it doesn't work. So if you want to open this up, I'll post this too, but if you want to ask questions on it, now's a good time. For the beginning, this is your parabolas. So I feel like with number 2, people got messed up with the number on the front of the x squared, and this is built into this assignment for a reason. You're going to see stuff like that. With the parabolas, you can't have anything in front of the squared term, so you have to move that 1/4 to the other side by multiplying by 4. Then it's in standard form, which is this, and then you can figure out your vertex. Your 4p would be 4, which means p is 1, and then from there you can do all the graphing. 3 was your flip of this, so here's the information and then get the equation. Any questions on 1, 2, or 3? So those are the parabolas. Okay, then 4 and 5 were your ellipses. 4 was the bigger number is 20, or the bigger denominator is 25, which means, and it's under the x, which means it's horizontal. My center is -2, 4. A squared is 25, so a is 5, and b squared is 4, so b is 2. We went right and left the a, up and down the b, and then c squared equals a squared minus b squared, which is 21, and c ends up being square root of 21. And then 5 was the reverse. Here's information about an ellipse. Find the actual equation. If the foci is 2, 0, and 2, 7 and -2, 7, then the center's halfway between them, which is 0, 7, and C is 2. That's what the foci tells you. And then it's horizontal. And then the length of the major axis, 6 should have been 2a, making a 3. Then you just had to use the equation to find b. B squared was 5. You're obviously going to get both types of questions on your test. Yeah.
Do we have this key?
I said I'll post it. Yeah, I'll post it on that assignment. And then 6 was your hyperbola. 7 was another hyperbola that was not in standard form yet. You had to divide everything by 64. So all that information's there. On 8, if you want to go back and practice it, especially because we haven't done the equations in a couple of days, change your conjugate axis to 6. Otherwise, the B was, or it was, right, the B was 6, which is bigger than C, and that can't happen. Like, C has to be the biggest for a hyperbola. So if you want to switch it and then try to work it out again, I would recommend at least getting that practice on this. So for the weekend, you obviously need to finish your 4-4 homework. Okay, that's on WebAssign. I would say if you want to go back through anything from WebAssign and check it from the equations, don't forget about those. Like the flip-flop is what we didn't do the last 2 days. So you want to make sure you're practicing that.